This is an interface that I made in 2008 while I was at Foria. The model underneath was by Jack Homer, Bobby Milstein, Gary Hirsch, who, if you continue on in the field and you read work, you'll see their names in a lot of places, especially if you're into the health vertical within the system dynamics field. So in this game, it's all about the whacked up American healthcare system and how crazy it is. And they gave you a bunch of different policy levers to pull. So you could expand insurance coverage, or change reimbursement rates for doctors, or enable healthy behaviors, or simplify insurance and go to single payer. If only we could do that. But anyway, so in this simulation, you make these decisions. You say, well, what would happen if we simplified insurance by going with standardization, or if we went with single payer, which obviously implies standardization? What would happen if we expanded primary care for disadvantaged people? Well, we could submit those decisions. And it then shows us a dashboard of our KPIs, our key performance indicators, our health costs per capita, our average unhealthy days per month, deaths per thousand, health equity index. And we can come back and we can do other policies. Well, what happens if, rather than doing single payer, we keep the expansion of primary care supply for the disadvantaged, we expand insurance coverage, we create pathways, and we submit that. We get different results, and then we can come back through and we can start comparing things. So we say, okay, what's the difference between test and run? Well, the difference in deaths per thousand is positive. It's in the right direction, even though it's a negative gap. Unhealthy days per capita, net benefit, whatever this is. I'm not totally familiar with all the concepts in this model. But anyway, you make decisions, you run, you compare. You make decisions, you run, you compare. This sim also had this other kind of weird mode in it, which allowed you, rather than running to the end, to run it in groups of 5 years. So do it 5 years at a time. So what if initially we work on disadvantage, then we work on expanding insurance coverage, then we work on, so it's a different mode for running the simulation. But ultimately, what you're doing in this game, in this simulator, is you're making decisions, you're looking at results, and you're comparing them to other results that you have generated. It's all comparative.
Really, can I ask a question?
Yeah.
Yeah. From this interface, it seems like there are many feedback loops behind in the model.
Yeah.
So if the players are playing this kind of game, how are they going to understand so many feedback loops when they combine different selections?
So this was one of the parts of this interface, which was kind of meant to explain that. And honestly, this interface didn't do a good job of that. This interface is really kind of a black box tool. So I'm not putting these forward as examples of perfect interfaces or great interfaces. I just want to familiarize you, because I kind of assumed, and you know what happens when you assume, that everybody here had no ever experience with an interface. Had never played one, had never seen one, had never looked at one. So I want to familiarize you with the variety of single-player interfaces, and then we're going to categorize. I'm going to show you 6 of them. And we're going to take these 6 and we're going to put them into categories, so that you can understand what the categories are, why you'd want to use an interface out of these categories, and hopefully have at least a picture in your head. When I say management flight simulator, you'll think of this. Well, actually, not think of this. Anyway, but yeah, so to answer your question though, in this case, the way that they wanted people to understand the feedback loops was by actually looking at this really complicated causal loop diagram. And the way that you would see the impacts is that you could hover over any of the areas within this causal loop diagram, and it would show you indicators relative to that sector within the model. This interface is 8 years old. This was, I'd say, a middling to poor technique 8 years ago, and it's aged even worse. I think there's a lot better things out there than causal loop diagrams. But not everybody agrees with me. Is that,
teaching interactive learning environments here, we had courses on that. I think part of that. and one of the important things then, and I think it still is even more important these days, is to link behavior to structure. In other words, to be able to gain a behavioral insights into the system by referring back to the underlying structure and identify where that behavior comes from. Now, we've been struggling with that for years and years and years, and it's really, really complicated. Not visually, but mathematically, to make sure that you're communicating the right message here. So your question is very much to the point and very much at the core of what we're always trying to do.
Yeah, so you can go really deep when it comes to loop dominance analysis, and you get into math, it makes my head spin. Ideally we would have a system like that, but that takes work more than I am capable of doing, at least at the moment. But there's other techniques for at least visualizing how structure and behavior interact. One of them that I like, obviously, because I made, is the Model Explorer that I made it for you. Another really good technique is storytelling, but none of these things are purely automated. The Model Explorer is, but storytelling isn't. You know, when you build these progressively revealing structures to explain where behavior is coming from, it's a really difficult problem to first know, even as the modeler, and then once you know it, how do you tell other people? But maybe we can actually, because that was actually the feature that he was referring to last night, that I ended up making. So as you build parts of a model, I made it so that the program automatically resimulates. So you put your stock in, you draw your flow. Now all of a sudden your graph of your stock changes to be. I'll show you. Anyway, so this is Benihana. So this is one of the more polished sims I've made. This was one of the sims for Harvard Business School Publishing. They took this sim and they sell it at $37.50 a seat. Pretty much incoming masters, MBA students, especially within process analytics. What students do in this game is they go through a series of challenges, and there's 6 of them. I actually only have access to the demo because I don't work at 4U anymore. I don't have the underlying model or source or anything like that, but I was able to get myself back into the demo. So I can at least demo it to you as they demo it to their customers. So Benihana is a hibachi restaurant, where one of the Japanese steakhouses where they cook in front of you. There's a bar, there's the restaurant area, and in that style of restaurant, this was actually a case study done by Harvard, one of the Harvard professors back in the 70s. They learned that there was a really important reason why they would force you to sit with strangers, why you always ended up at a table full of 8 people. And that's called batching. What this simulation actually teaches you, is really kind of funny, is that when you batch actually, let's run a no batching here. So when you batch your customers, well, let me show you a non-batching case. Okay. So when you don't batch your customers, they come in, they sit at the table, and there's all these empty seats. And then when the restaurant gets filled, they come to the bar, they sit in the bar. As tables finish eating, people leave, they come back, they're waiting here in the bar. And that was, kind of the structure of the Benihana restaurant was you had a bar, you had the tables, you left. The whole point was to maximize profit. So when you don't batch customers like this, you can see your nightly profits on average are negative $282. You've lost 96 customers on average each night. So lost means there's no space for them in the bar. They get to the bar's full, the maitre d' tells them they've got 2 hours to wait for a table, and they say, and leave. Whereas when you batch, you have a totally different outcome. So, every time I hit that simulate button, it's actually running for me 20 different runs. and it reports the average, the minimum, and the maximum of the outputs, the key outputs of the simulation being profit and lost customers. Here's just a whole bunch of other businessy data about how the restaurant is working, but we don't really care because the point is just to show when you run this simulation, what you're doing is you're comparing the differences. So when we batch, what ends up happening is you have 100% utilization within your restaurant, which means you can pack more people in the building. And when you pack more people in the building, people spend a good long time here at the bar sipping down drinks, and you make a lot of money on drinks, and you make a lot of money from the tables because you never have no butts and seats, which means your bounce rate, your lost customers, is a heck of a lot lower. So that was one of the key takeaways from this case study, but they explore within this simulation a whole bunch of other different decisions that you could make. One of the other benefits, of course, of batching is that when a table of 2 arrives, you sit them at the bar first. So everybody goes through the bar. You don't immediately seat people. That means everybody is buying at least a drink. And restaurants make a lot of money on drinks, so they like that. Anyway, though, so this is another one of these simulations where you're comparing results. Every time you run it, you're looking at the average, the min, the max, and then 20 individual runs of this model. And I can animate any one of them. There's a variety of challenges. Well, what if you make the bar bigger, or the restaurant smaller, or vice versa? What if I make the restaurant really big and the bar really small? But anyway, there's 6 of these challenges, and what's really cool about these simulations from Harvard is they do more than just, drop a model on people's laps. So with these simulations, when you buy one as an instructor, you get a whole, curriculum guide. How do you integrate this within your course? You get, all of the introductory materials. It's fairly immersive, this simulation, when you actually play it in the real world. But what you get out the other end is really, really important. So these simulations all have a student side, and they all have a facilitator side, an instructor side. So the instructors of these simulations can find out how, Audrey did in this sim. They can figure out, they can look at a histogram of all of the different best scores, best profits for the night. They can look at and actually replay individual runs. So what will often happen is a professor will assign a simulation for homework after explaining the concepts of batching or explaining, any one of these concepts. And the students will run the model that night. The professor, in the morning will come in, will take a look at this histogram of results. They will then go find interesting runs, and the next day they'll go back and they'll actually present the simulation, individual cases that students ran back to the class as a whole. So there's actually a feedback loop there within the learning. You don't just play the game and move on. You get introduced, you play the game, you do some learning on your own. You then have that reinforced in class, where in class they then take that interface and shove it back in your face to kind of really drive the point back home. And actually, at the time that this was made, one of the really big things that they were really proud of is that you could download a series of debriefing slides, which was based on the simulation data that was generated by your class. So it would customize this PowerPoint presentation for you based on what your class had done. Because teachers are really, really busy people, as I'm sure many teachers will tell you. And the last thing they want to do is sit there and make custom PowerPoints for every possible outcome of the simulation. So the simulation kind of did that for you. All right. I actually haven't looked at one of these in a really long time, but yeah, so it would show you all of the different kinds of profit versus utilization. I think, yeah, and so it actually builds these histograms. These histograms were based on your class's results. Okay. So now we've kind of looked at 2 of these simulations where you look at a lot of results, you compare the differences between the 2. Let's do something else now. Let's look at a game where it's a bit more immersive, where you're playing, as a competitor within a market. That's the other debrief. Okay, so in this one, this was all about pricing and how to price properly. Another one of these MBA student simulations. So Benihana, as you can imagine, was actually much more of a discrete event, agent-based model. This is pure system-dynamics. And the thing is, the students who play this game have no idea what system-dynamics is. But they don't need to know. They're learning the key results and the key insights of the system-dynamics model without ever knowing what system-dynamics is. So it's not always important. It's based on who your audience is, whether or not it's important to tell them that system dynamics is a thing to begin with. Maybe only the really advanced students who really take an interest will make it to that level of knowledge. But the most important priority, at least from the professors who play these games in class, is that they learn about batching. They learn about pricing strategy, not that they learn about this wonderful method that we're all so interested in. So anyway, in this game, you play as a rental car company, and you got to decide how you're going to price your cars in 3 different cities in Florida based on the weekday and weekend price, fleet sizes. You get all this information about unit sales, capacity utilization, fleet size, things like that. So you make decisions and you advance time. You make a decision and you advance time. So this is a different kind of gameplay, a totally different style of running a model. So the other 2 we looked at were comparing. What's the difference? This, you have no baseline, there is no comparing. This is trying to be real world, trying to put you in a semi-stressful situation. Because often what they'll do in these classes is they'll have the kids compete. And if you're in the top 10%, you get the A. If you're in, totally different outlook here. In this simulation, you're never going to hear about system dynamics. You're never going to learn about how any of this works. All you're going to do is learn about pricing strategy. And it's really effective at teaching people pricing strategy. And so again, this sim has its own debrief page for facilitators. It has all of its own introductory course material. You take a look at what are the best scores. You take a look at the outputs. You as a facilitator have control over whether or not the students can see high scores and how the simulation is set up. So in this game, there's actually 3 different scenarios. So as you can imagine, if this game only had one scenario, you play it once, you play it again, it'd be the same thing. So in order to add some replayability to this sim, we made different scenarios. So you can include weekend pricing or not. You could deal with regions. You can change the way that demand grows, and demand is not something that's exposed to the students. So this is another way of kind of dealing with one of the cons of this kind of simulation is replayability. Here, in order to address replayability, we added scenarios. Alrighty. So that was 3 of them. Let me show you C-Learn. C-Learn is what? John Sterman and MIT, and there's a whole group of them. And I don't remember everybody's name. I have this link in the PowerPoint. PowerPoint is silly. Yeah, so Sea Learn is all about the climate, all about looking at the gap in global temperature rise based on a variety of policies. It's another one of these comparative simulations. Make some decisions, look at results, compare them to base cases, compare them to other runs that you've ran. So some of the sims that we looked at, Healthbound was custom built. In fact, all three that we've looked at so far are all custom built sims. Pricing and Benihana were built in 2010, Healthbound in 2008. This was actually drag and drop together. I didn't build this. This was built in the UI designer at Forio, which is one of the drag and drop tools, kind of like the architect interface layer. But anyway, in this sim, you see results in your key indicators, temperature changes over pre-industrial. You have a whole bunch of decisions to make. You run, you save, you compare. Should be familiar now. So I can come in, I can run, look at results, compare them, and learn about how to manage the climate. I think we've seen enough examples. I think now we've got a pretty good idea of what the potentially different kinds of simulations are. So I've classified them. And this is stuff that I've invented. I didn't pull it out of the literature or anything like that. So comment. Does this make sense? So I see there's really 2.5 kinds of single-player simulations. There's scenario analysis tools. So insights are distilled from reviewing the results of many runs and comparing the results between them. Then there are management flight simulators. Insights is distilled through experience. So you do it within a single scenario. Think of SimCity. How many people have played SimCity? I think Will Wright actually did a bunch of system dynamics before or maybe after SimCity. Even though that wasn't purely a system dynamics model, it was definitely influenced by system dynamics. You could think of SimCity as a really big interactive learning environment. And that would be a good example of what I've termed a management flight simulator. So you learn through experience, through doing. Whereas the scenario analysis tool, you learn through gaps, through subtracting, through comparing. Oh, this is higher than that. This is lower than that. Whereas in management flight simulators, it's, I raised profit to $500. I cut costs to $200. This is all about specific real world things. This is all about the differences between things. So we build scenario analysis tools when we're not really sure what the outcome's going to be, but we can say this is better, this is worse. We build management flight simulators when we want people to get involved typically when the case isn't real. Like that Benihana simulation isn't really based on real Benihana numbers. Those numbers are all fake and made up. But the point is, the students don't know that. The students don't even care because they're being graded on. Their reward for the simulation is based purely on their performance in that game. Hybrids are a subcategory, really, and they're weird. I've never really seen one done really well. An example of a hybrid that I showed you today was that Healthbound, where you could run the whole time. You could run in 5-year increments. You didn't necessarily have to use any of the comparative parts of Healthbound, but really the tool isn't all that useful unless you are comparing. It's kind of weird. And maybe one of you guys has more insight into these hybrid simulations, ones that, yeah, you're doing some comparing, and you're looking at the differences between base cases and generated runs, but you're also running them, year by year. The closest hybrid I have is actually that laundry detergent case. Let me show that to you really quickly. We'll just blast through that. Where you start out with a story here, and this story is based on a causal loop diagram. So this is, one of the techniques of teaching people about how models work underneath.
If the game is small enough, like the loops are small enough to understand, then this is a very effective way.
Right. So in this game, you're making a decision about how much to spend on marketing to drive adoption. So you're playing step by step, step by step. But this game has 2 scenarios within it. And at the end, you can compare results across the scenarios. So I'm just generating different behavior here. So when you're done playing this game, yeah, you've learned something from playing it through as a game, but then we hope to reinforce at least a little bit more of that learning through looking at the differences between your runs. So you can say, oh, when I spent money and then stopped spending money, yeah, I lost money for a while in the middle, but by the end of the simulation, I had made it up. Versus, not spending anything ever. Well, actually spending $1,000 the whole time. But again, hybrid simulations are weird. I've never, like I said, really seen one that works great. Alright, so let's go into what these things are. So a scenario analysis tool simulated with a single action. You hit run, it goes. There's no animation, there's no revealing. It's just, give me the damn results now, please. Heavy use of comparative graphs. Bonuses, you have cross-run statistics. So think back to Benihana, where it showed you the minimum, the maximum, the average. Think back to Healthbound, where it showed you the standard deviation of the difference from the means. Scenario analysis tools, they don't have information hiding. So one of the biggest tools in your toolbox as an interface developer, especially when you're developing these management flight simulators, is information hiding. You're not telling people about certain things. You're not showing them the demand curve. You're not showing them what their competitors are doing, because they don't know that in the real world. And when we're building these scenario analysis tools, everything's on the table. We're not hiding stuff. The scenario analysis tool is something that people are using to make decisions. You give them to managers. You give them to higher people within the organization. They're not played by as many people, but the people who are playing them typically have control over these decisions in the real world. Whereas these step-by-step sims, these management flight simulators, these games are typically played by larger numbers of people, often to teach them about a concept, but they don't necessarily have control over a decision within the system. And that's just kind of, I don't know why, but that's just kind of what I've experienced. So in these scenario analysis tools, there's a lot of learner-based discovery. So the modeler isn't saying this is the answer. Of these scenario analysis tools, you're asking what if all the time. What if I play with profit? What if I reinvest into the business? What if I made single-payer healthcare in America? Also in scenario analysis tools, back to the information hiding, assumptions are made explicit and available. So these are tools where people tend to want to get into how the model works, whereas in the management flight simulators, oftentimes people don't care. They take them as a given. They're black box. You play the game. You learn the message. You move on. So when do you use a scenario analysis tool? When delivering to a specialized audience, managers, decision makers, implementers. You do it also when your key insights are best understood as derivations from a base case. So that's another way of saying what I was trying to say before, which was management flight simulator in